Right now, tonight, go outside. If you can get away from the city lights, just drive 20 minutes in any direction until the orange glow fades, and look up. You will see something that has confused and humbled every human being who has ever lived. Stars, not many of them relative to what is actually out there. On a perfect night, far from any city, the human eye can see roughly 5,000 stars without any help. 5,000 points of light scattered across the dome above you. It feels like a lot. It feels, honestly, like everything. It is not everything. It is almost nothing. The Milky Way alone contains somewhere between 100 billion and 400 billion stars. Let that number sit for a moment. If you counted 1 star per second starting right now, it would take you over 3,000 years just to count the lower estimate. You would have started before the Roman Empire existed. You would finish long after every building standing today has crumbled to dust, and you would still only have counted our galaxy. One galaxy out of roughly 2 trillion galaxies. That is the current scientific estimate of the number of galaxies within the observable universe, each one containing hundreds of billions of stars, each star potentially surrounded by planets. The observable universe stretches approximately 93 billion light-years across. 1 light-year is nearly 10 trillion kilometers. The numbers stop meaning anything to the human brain. They become symbols on a page. They become noise. But here is what should stop you cold. On that boundary, the edge of the observable universe is not the edge of the universe. It is only the edge of what we can see. It is not a wall. It is not where things end. It is simply the limit of how far light has had time to travel to us since the universe began. Beyond that boundary, space continues. The universe keeps going. We just cannot see it. We cannot reach it. The light from those regions has not had enough time to arrive, and it never will, because the universe is not only vast, it is expanding, and not just expanding, accelerating. Right now, as you read these words, the fabric of space itself is stretching in every direction. The galaxies at the edge of our visible universe are not just far away, they are getting farther, fast, much faster than light can travel. Which means that over time, the light from more and more of the universe will simply never reach us. We are not at the center of the universe. There is no center. But we are, in a very real sense, inside a shrinking bubble of visibility. A bubble that will, over the next trillions of years, grow increasingly dark. The lights, one by one, will go out, not because they have died, but because they have moved so far away that their light can no longer cross the distance to find us. And when the last light arrives, when the very last photon from the last reachable galaxy finally reaches a detector, if anything is left to detect it, the universe as we will have known it will be over, not with an explosion, not with a collapse, with a silence. Let us begin where you are. You are on the surface of a planet that is approximately 12,700 kilometers in diameter. If you drove a car at highway speed without stopping, it would take you roughly 7 months to reach the other side, through the Earth, which is of course impossible, but the distance is real. This planet orbits a star, our Sun, at a distance of about 150 million kilometers. Light from the Sun takes 8 minutes and 20 seconds to reach you. This is not a metaphor. If the Sun vanished right now, you would not know for 8 minutes and 20 seconds. You would feel its warmth, see its light, and it would already be gone. Our solar system from the Sun to the farthest reaches of the Oort cloud extends roughly 100,000 astronomical units from its center. At the speed of the fastest spacecraft humanity has ever launched, Voyager 1, yet moving at about 17 kilometers per second, it would take approximately 75,000 years to reach the nearest star. Voyager 1 was launched in 1977. The ancient Egyptians were still building things 75,000 years ago. We are not even close. The nearest star to our Sun, Proxima Centauri, is 4.24 light-years away, meaning the light you would see from it left that star 4 years ago. You are looking into the past. Always. Every time you look at the night sky, you are looking at history. The star you see might not even exist anymore. Its funeral could have happened 1,000 years ago, and the news is still on its way. Now step back further. The Milky Way is a barred spiral galaxy approximately 100,000 light-years in diameter. Our solar system sits about 26,000 light-years from the galactic center. If you could somehow see our galaxy from outside, if you could hover above it and look down, you would see a luminous spiral, turning slowly, one full rotation taking roughly 225 million years. In the entire history of human civilization, all of recorded history, everything we have ever built or written or remembered, the Milky Way has not completed even 0.1% of a single rotation. We are passengers on something so slow we cannot feel it moving at all. Here is the gut punch. The Andromeda Galaxy, our nearest large neighbor, is approximately 2.5 million light-years away. When the light now arriving from Andromeda first left that galaxy, our ancestors were not human. They were early Homo species, making crude stone tools, barely surviving. That light has been traveling through the absolute void of space for 2.5 million years, and it has only just reached your eye. And Andromeda is considered close. It is practically next door. The observable universe extends to approximately 46 billion light-years in every direction. Not 46 billion years of travel time. The universe has been expanding the whole time, so the objects whose light took 13 billion years to reach us are now much farther than 13 billion light-years away. Space was moving while the light was moving. And beyond the 46 billion light-year horizon? The universe does not stop. Current models suggest the total universe could be at least 250 times larger than the observable portion. Some estimates go far higher. We genuinely do not know. We cannot know. No signal, no light. No information of any kind from beyond that horizon will ever reach us. Those regions are permanently, irretrievably beyond our reach. Not because we lack the technology, because the laws of physics make it impossible. They might as well not exist. But here is what should keep you awake at night. It is not the size of the universe that is the most vertiginous thing. It is what the expansion means for the future. Right now, we can observe approximately 2 trillion galaxies, but the universe is accelerating outward, driven by what scientists call dark energy, a property of space itself that pushes everything apart. Over the next few trillion years, all but the galaxies in our immediate gravitational neighborhood will have receded so far and so fast that no light from them will ever reach us again. Future civilizations, if any exist in 1 trillion years, will look up and see only a small island of galaxies surrounded by perfect empty darkness. They will have no evidence that anything else exists. No ancient light will have survived the journey, no record of 2 trillion galaxies, no hint that the universe was ever anything other than local, small, and nearly empty. The cosmos will have erased itself from its own sky. And then, far beyond even that moment, after the stars have burned out one by one, after the last red dwarf smolders and dims, after black holes have evaporated over timescales so long that the current age of the universe is a rounding error, comes the silence we started talking about. The last light, not a dramatic ending, not a shockwave or a final explosion, just a single photon. The very last one released from the last dying object in our visible cosmos, traveling through the dark, growing cold, until it too is stretched by expansion until it carries no energy at all. Gone. And then, what follows? This is the question the universe leaves us with. Not loudly, not with urgency, it just waits. Here is what we know. The observable universe is roughly 93 billion light-years across. It has been here for 13.8 billion years. The stars in it will burn for, at most, another 100 trillion years before the last one gutters out. Then the era of stellar death begins. Black holes will reign over a cold, dark cosmos for something on the order of 10 to the power of 67 years, a number so large that writing out all its zeros would take longer than the current age of the universe. And then even those will be gone, dissolved by the slow drip of Hawking radiation. After that, the best models we have suggest the universe reaches a state called heat death. maximum entropy. Everything is uniformly cold, dark, and evenly spread. No structure, no energy gradients, no possibility of any event. Nothing happens, ever again. Not because anything is preventing it, because there is nothing left to happen. This is not science fiction. This is the current scientific best guess at the default fate of the universe, assuming the expansion continues and dark energy holds. And every observation we have made so far suggests that it will. Now bring this back to you. You are standing on a rock, orbiting a star, inside a galaxy, inside a cluster, inside a supercluster, inside the largest structure we have yet mapped. And all of it, every atom you are made of, was forged inside dying stars. The iron in your blood was synthesized in the core of a star that exploded billions of years before the Earth existed. You are not separate from the cosmos. You are a piece of it that became temporarily aware of itself. Carl Sagan said we are a way for the cosmos to know itself. That is not poetry. It is physics. The universe, for at least a brief window, has arranged matter into forms capable of looking up and asking, what is all this? Where does it end? How did it begin? What comes after? And the answer the universe offers when you press it hard enough is both devastating and strangely beautiful. It ends in silence. The darkness that follows is not threatening. It is just the default state of things. Structure, stars, planets, life, thought, is the anomaly. The exception, the brief improbable deviation from the long baseline of nothing happening. And we are inside it, right now, at what cosmologists call the stelliferous era, the age of stars. We are alive during the time when the universe is doing its most spectacular thing, burning, exploding, creating, colliding, evolving. We are not late. We are not at the end. In terms of the total timeline of the universe, we are astonishingly early. The universe is 13.8 billion years old. The stars will shine for another 100 trillion. We are in the opening chapter, the prologue, almost, which means the darkness is not close, not by any human measure, but it is coming, slowly, inevitably. And the light that exists right now, every photon, every stellar fire, every galaxy rotating in the dark, is finite. There is only so much of it. And when it is gone for a duration that makes its entire existence feel like a single breath. One breath in an airless room that has no walls and no ceiling and no floor. What do you do with that? You could feel small. Most people do, the first time the scale lands. But there is another way to hold it. You are made of atoms that have existed since 3 minutes after the Big Bang. You will not be destroyed when you die. You will be returned. Scattered back into the world, into other forms, cycling through matter and energy the way matter and energy have always cycled. You will, in some diffuse chemical sense, outlast the civilization you were born into and the species you belong to, and perhaps even the planet you stand on. And right now, in this exact moment, you are here, awake, looking up, capable of understanding, however imperfectly, the shape and scale of everything that exists. The universe does not know you are here. It does not care. It has no preference for your survival and no interest in your questions. It will continue expanding regardless of whether anyone is left to notice. But you are here, and you noticed. And somewhere in the incomprehensible dark, 46 billion light-years away, the last light that will ever reach us is already traveling. It left a long time ago. It is on its way.